All right, in example 6, we're comparing radical functions. So we have two different functions here. That's what we have got to understand is we have p of x, which is the equation here, and then q of x, which is drawn for us. So we notice that this right here is q of x. We have q of x, which is drawn for us, is a square root, right? So its domain starts here and then goes positive, right? So its domain is 1, 2, 3, 4, 5, 6. X is greater than or equal to 6. Okay, that's terrible. Okay, and then we notice that, hey, its range goes down, right? So its range is from negative infinity. Oh, that's ugly. Negative infinity to 0, that y value, right? Or you could say y is less than or equal to 0. You could say that. Or you could put it in interval notation, one of the two. All right. And then our x-intercept is at 6. So x equals 6. Our y-intercept, it doesn't cross the y-axis, so none. Okay, this positive negative is, where's our graph above the x-axis? Where is it below? Where our graph is only below the x-axis, correct? So it's below the x-axis at everything greater than 6, right? It's negative. Everything greater than 6, because at 6 it's at 0, right? And 0 is not negative. So, and then increasing or decreasing, decreasing as I go from left to right, what's my graph doing? As I go from left to right, my graph is drawing down, so that means it's decreasing. So from x greater than or equal to 0, my graph is decreasing. Okay, so those are all kind of the characteristics of this square root function q of x. Now we're going to go ahead and graph p of x and then compare the same things. So we notice that this is a cube root, right? So again, if I set this equal to 0, I get 6, right? I get x is equal to 6. And then my y value, nothing's being added to it, so I know my y value is 0. So there's my central point, 6, 0. So look, it shares that central point. But then if I was to graph a cube root, I know my domain of all cube roots is all real numbers, right? All reals. Okay, and the range I know is all real numbers. Now, what's a little bit different about this one is my x-intercept's the same, so x equals 6, right? It crosses the x-axis, so I could easily just set this equal to 0 and see and solve this, right? Or I could graph it and see where it crosses the x-axis to find my x-intercept if I can't find it. But a lot of times it will have to do with your domain sometimes, but sometimes it won't. Like the previous problem that we did, our graph was like this, and then it crossed right here at that point, right? Okay, and then so sometimes you have to put it in your calculator to see where it crosses the x-axis. Same thing with the y-intercept. This one we'll have to change it a little bit to find it. Okay, so we know because this is a 2, it's going to grow faster, right? So it's going to have what we call a dilation. If I spelled that correctly, of 2, right? So it has a dilation of 2. So again, what's really the fastest way to do that is really just to go 1 over and either down 2 and hit your point or go up 2 and hit your point. But because this is a negative 2, we're just going to go over 1 and it would go down 2. So actually it hits the same point. So actually this one actually has a dilation 2 of 2 as well. And that's when you just go over 1 and down 2, which basically means I'm just plugging in 7 into my equation. 7, I'd get the cube root of 1. Cube root of 1 is 1. 1 times negative 2 is negative 2. So I get this point over 7 down negative 2. But how you find it from a graph is you can just go over 1, and then how much do you have to go down or up to hit your graph? And you have to go down 2. So the equation for this would be a negative 2 as well, but with the square root. The square root of x minus 6, right? Because I had to go 6 over 1, 2, 3, 4, 5, 6. So this would be the equation, square root. All right, so there's my dilation, okay? And then it hits the same point, right? So it hits this same point right here. So my graph actually goes the same exact way as that, but then doesn't it also go this way? Because it's a cube root, so it's also going to hit this point up here over 1 up 2. And it's going to look something like that. So that's what that's going to look like, because that's my domain and my range, right? All real numbers and all real numbers. So my y-intercept, if I want to find that, that's when I plug in 0 for x. So I'd plug in 0 for x, and then I'd get cube root of -6, which I'm going to have to do on my calculator, and then I have to times that by -2. So I quite don't have a calculator on me, so I can't really say what this y-intercept is, because I would take the cube root. So the y-intercept is the cube root of -6, which is like -1 point something, times a -2. So whatever that is on my calculator, that would be my y-intercept. Positive and negative, here's where it changes a little bit. I know the negative is from below the x-axis, right? So that's from 6 onward. It's below, my graph is below. So it is negative from x is greater than 6. And then it's positive above that, right? So we're positive, we're above the x-axis. So it's positive x is less than or equal to 6, right? Because this x at 5, it's positive. This x at 4 is positive. This x at 3, it's positive. So x less than or equal to 6, it's all positive numbers. Okay, even though I kind of spelled positive wrong there. All right, then increasing and decreasing from left to right. Remember, don't worry about the arrows on increasing, decreasing. Just think, if I draw this from left to right, my graph is going down the whole way. So this is actually going to be decreasing for all real numbers, all over its domain, real numbers. Okay, so those are the things that you would compare. Another thing that you could compare, I said dilation, but also you could probably compare if there's any reflection about the x-axis, reflection about the y-axis, which both of these reflect about the x-axis because there's a -2 out here, and because our dilation for this one is over 1 down 2, it actually has a dilation of 2 as well, but because of that negative, it's going to be reflected about the x-axis.